Good day. This presentation will tackle about the descriptive inorganic chemistry of the elements, niobium and tantalum. Let's start on niobium. Here is the general information about niobium. Its symbol in the periodic table of elements is Nb. Its atomic number is 41. It is a gray metallic solid at room temperature. It belongs to group 5 period 5 in the periodic table of elements, and it is found in the D block or the transition metals block. Niobium is from the Greek word niobe, meaning daughter of Tantalus. Tantalum is closely related to niobium in the periodic table. On your right is the picture of niobe, inspired by the artist Giorgio Summer. Niobium was discovered in 1801 by Charles Hatchett in an ore called columbite sent to England in the 1750s by John Winthrop the Younger, the first governor of Connecticut, USA. Hatchett called the new element columbium. He was not able to isolate the free element. There was then considerable confusion concerning the distinction between niobium and tantalum, as they are so closely related. This confusion was resolved by Heinrich Rose, who named niobium in 1846. The name niobium is now used in place of the original name columbium. The metal niobium was first prepared in 1864 by Blomstrand, who reduced the chloride by heating it in a hydrogen atmosphere. The name niobium was adopted officially by IUPAC in 1950, but a few commercial producers still like to refer to it as columbium. Niobium is a shiny, white, soft, and ductile metal, and takes on a bluish tinge when exposed to air at room temperatures for a long time. The metal starts to oxidize in air at high temperatures, and when handled hot must be done so under a protective atmosphere so as to minimize oxide production. Its density is 8,570 kilograms per cubic meters. The molar volume of niobium is 10.83 per cubic centimeters. Other properties include its metal hardness, electrical resistivity, and its thermal conductivity. Its melting point is around 2,477 degrees Celsius, while its boiling point is around 4,744 degrees Celsius. Its enthalpy of fusion is 26.8 kilojoules per mole, 690 kilojoules per mole on its enthalpy of vaporization, and atomization enthalpy is 733 kilojoules per mole. It has a body-centered cubic crystal structure, as presented in the images below. Let us proceed to the different compounds of niobium. First up are its fluorides. This includes niobium trifluoride, niobium tetrafluoride, and a niobium pentafluoride tetramer. Known chloride of niobium are niobium trichloride, niobium tetrachloride, and niobium pentachloride. The oxides of niobium are simply niobium oxide, niobium dioxide, and diniobium pentoxide. The picture on your right shows a sample of niobium pentachloride, but a probable mixture of niobium oxide and niobium oxychloride. Its bromides comprise niobium tetrabromide and niobium pentabromide. The iodides of niobium are niobium triiodide, niobium tetraiodide, and niobium pentaiodide. On the other hand, niobium disulfide is the sulfide species that is currently known. Niobium diselenide, niobium ditelluride, niobium nitride, and niobium hexacarbonyls are the other known compounds of niobium. Next stop is the reaction of niobium and other substances. Niobium does not react with air and water under normal conditions. This is because the surface of niobium metal is protected by a thin oxide layer. Niobium does not react to halogens upon warming to form niobium halides. The following are the net reactions of niobium forming its respective halide compounds. Niobium can be dissolved with a mixture of hydrofluoric acid and nitric acid. Niobium is resistant to bases, but it can also be dissolved slowly. Finally, here is the application of niobium to modern technologies and stuffs. The following uses for niobium are gathered from a number of sources as well as from anecdotal comments. Niobium metal has a number of important uses. It is a component of some stainless steels and also alloys with non-ferrous metals. These alloys have good strength and other properties, and are used in pipeline construction. The metal has a low capture cross-section for thermal neutrons and so finds use in the nuclear industries. The metal is used in arc welding rods for some grades of stainless steel. It is used in advanced engineering systems, such as those used in the Gemini space program. Some magnets contain niobium, and superconductive magnets are made with NBZ or alloy wire. Because of its bluish color, niobium is apparently being used for body art products, such as navel rings. Tantalum is the next element. Here is the general information about tantalum. Its symbol in the periodic table of elements is Ta. Its atomic number is 73. It is a gray-blue solid at room temperature. It belongs to group 5 period 6 in the periodic table of elements, and it is found in the D block or the transition metals block. Tantalum comes from the Greek word tantalos, meaning father of niobium. Tantalum is closely related to niobium in the periodic table. Niobium was discovered in 1802 by Anders Gustav Ekeberg, but many chemists thought niobium and tantalum were one and the same. Some felt that perhaps tantalum was an allotrope of niobium. Later, Rose, in 1844, and Murignac, in 1866, showed that niobic and tantallic acids were two different acids. The first relatively pure tantalum was produced by von Bolton in 1907. Tantalum is a greenish silver, heavy, and very hard metal. When pure, it is ductile and can be drawn into fine wire, which can be used as a filament for evaporating metals such as aluminum. Tantalum is almost completely immune to chemical attack at temperatures below 150 degrees C, and is attacked only by hydrofluoric acid, acidic solutions containing the fluoride ion, and free sulfur trioxide. The element has a melting point exceeded only by tungsten and rhenium. Its density is 16,650 kg per cubic meters. The molar volume of tantalum is 196 cubic centimeters. Other properties include its metal hardness, electrical resistivity, and its thermal conductivity. You can see at the image below the grayish silver color of tantalum. Its melting point is around 3017 degrees Celsius, while its boiling point is around 5458 degrees Celsius, and its enthalpy of fusion is 203 kilojoules per mole. It has a body-centered crystal structure as shown. Next are the compounds of tantalum. A known hydride of tantalum is ditantalum hydride. Its fluorides are tantalum trifluoride and tantalum pentafluoride, that is shown on your right. The chlorides of tantalum comprises tantalum trichloride, tantalum tetrachloride, and tantalum pentachloride. Other halides of tantalum are tantalum tribromide, tetrabromide, and ditantalum dicabromide. Its iodides are tantalum tetraiodide and tantalum pentiodide. The oxides of tantalum are tantalum oxide, dioxide, and ditantalum pentoxide. Tantalum sulfide, tantalum diselenide, tantalum ditelluride, tantalum nitride, and tantalum hexacarbonyl are the other known compounds of tantalum. Let us proceed on the reaction of the different compounds of tantalum. Tantalum does not react with air and water under normal conditions. This is because the surface of tantalum metal is protected by a thin oxide layer. Tantalum does not react to halogens upon warming to form tantalum halides. The following are the net reactions of tantalum forming its respective halide compounds. Tantalum appears not to be attacked by many acids at root, but does dissolve in hydrofluoric acid or fuming sulfuric acid. Also, tantalum metals are commonly attacked by molten alkali. Finally, we proceed on tantalum's application. Tantalum metal has a number of important uses. It is used to make steels with desirable properties, such as high melting point, high strength, good ductility. These find use in aircraft and missile manufacture. It is very inert and so useful in the chemical and nuclear industries to line reactors. Tantalum wires were those used first for light bulbs. Now tungsten is preferred. The metal is immune to body liquids and the body tolerates the metal well. Therefore, tantalum has widespread use for surgical use. For instance, it can be used in sutures and as cranial repair plates. The metal is used in the electronics industry for capacitors. The oxide is used to make special glass with a high index of refraction for camera lenses. And that is all for the descriptive inorganic chemistry of niobium and tantalum. I hope you learn a lot.